So let's look at another example of using a sign chart to solve these problems. This is again a polynomial. In our next video, we will be doing a rational function to see how those work. So here we have our polynomial. It does have some multiplicities, right, that will change whether it crosses the x-axis or not. The first thing it asks is, where is f of x equal to 0? So where the function equals 0 is the x-intercepts, or the zeros. Okay, you can see we have a few of them. Now, -3 does not have an x with it, so that is not a 0. Okay, we have x plus 5 to the third equals 0, so x equals -5 from this one. X minus 1 squared equals 0, so x is equal to 1 here. And then x minus 8 equals 0, so x is equal to 8. Okay, so the answer to part A is -5, 1, and 8. That's where f of x equals 0. To answer B, C, D, and E, I put them down here so we'd have a little more room for our sign chart. We need to make a sign chart, and that will answer all four of those all together. So we'll start our sign chart up here. We have 3 zeros to put on it, -5, 1, and 8. Okay, and it will head off to infinities at the ends. Okay, so remember, to start this sign chart, what we have to do is we don't put -5 into the equation, okay, because guess what? Then the equation will equal 0. It will not be positive or negative. We need to put a number smaller than -5, so like -6. We need to put a number between -5 and 1, so I'm going to put 0 in. Sorry, I'm going to write them above. So lessons learned from years of teaching this: write your test points in one space and write your zeros in another. The reason is your answers will have zeros, but your answers will never have test points in them. Okay, and I've seen far too many students put test points in their answers. You can't use test points in your answers. I mean, I picked 2 here. Someone else is definitely going to pick like 4 here or 7, right? So you wouldn't even have the same answers as other people, right? You have to use the zeros that are standard for the problem. I'm going to put 10 over here. Okay, just to be fancy there. All right, so now I'm going to plug in all my test points and see if the function is positive or negative at those test points. So if I plug in -6, I have -3 times -6 plus 5 cubed times -6 minus 1 squared times -6 minus 8. That is a lot of negative signs, right? Okay, so I have a negative out front here. This is -1 and it's cubed, so it stays negative. That's 3 negative signs. This is negative, but it's squared, so 2 negative signs make a positive. This is negative and nothing is done to it. Okay, now I count up my negatives. 1, 2, 3 of them. 3 negative signs will always make a negative. Okay, oh, you know what? I'm going to do something a little different in this one. Ooh, oh, I just lost a 0. What was that? -5, right? Okay. So some people put the big negative signs and the positive signs, and some people would actually do this. They would write negative, okay? Because this whole area is negative, so we need to know that. All right, now I'm going to put 0 in. So -3 times 0 plus 5 cubed times 0 minus 1 squared times 0 minus 8. Okay. Negative out here. This is a positive number. This is -1, but it's squared, so that's a positive. And this is a negative number. Okay, 1, 2, 3, 4 things, but 2 of them are negative. Okay, 2 negative signs, even number of negative signs makes a positive. All right, now I'm going to put in the number 2. Okay, -3 times 2 plus 5 cubed times 2 minus 1 squared times 2 minus 8. Okay, so there's a negative out here. This is a positive. This is a positive. And 2 minus 8 is a negative. Okay, so I'm seeing 2 negative signs again. So this is again a positive. Okay, finally, I'm going to plug in 10 for my last test point. -3 times 10 plus 5 cubed times 10 minus 1 squared times 10 minus 8. Okay, so I've got a negative out here. This is a positive. This number is positive, and 10 minus 8 is positive. Okay, so even though I plugged in a positive number 10, this time I am getting a negative because I have one negative sign. Okay, so this region of my graph is negative. This region of my graph is positive, positive, and then negative. Okay, so in other words, if I plug in -2 into this function, I don't know what number that is, but I know it will be a positive number. Okay, if I plug 100 into this function for x, I know that that will be a negative number. That's what it's telling me. Okay, so now we will answer all of the questions. Where is f of x less than 0? Well, that is where the sign chart says negative. So that would be negative infinity over to -5. Okay, then it's positive and positive, and then it would be 8 over to infinity. Okay. Let's do D next, okay? Because it says less than or equal to. So what we have to think about is let's change the brackets if we should. So less than would be negative infinity to -5, but now we want to include the -5, 0. Okay. And then here we would use a bracket on the 8. Okay. All right, now we're going to do where is f of x greater than 0. Greater than 0 means the positives. So this, in other words, is the, not positives, the negatives. I should have written this already. The negatives and the zeros. I don't want to put a plus sign. That's weird, right? The negatives and the zeros. This is just the positives. So the positives are here and here, and it is 2 intervals, -5 to 1 and 1 to 8. Okay. Then for this, we need the positive. Oh, I'm running out. You can see this. Positives, and this is the positives and the zeros. Okay. So the positives, so we have -5. We won't stop at 1. We'll go all the way to 8. Okay. I like to highlight that one. So, when we were just dealing with just the positives, we would be here to here and here to here. But then if we want to include the -5, the 1, and the 8, look how that becomes one interval instead.